sort of the relative strengths and weaknesses of, large scale RCTs versus smaller scale and even N of one experiments
Yeah.
such as those that you've done.
Right. So, a couple things on N equals one. Let's just first clarify, like, this is legitimate science. Like, there are top scientists at institutions like Stanford, Harvard, elsewhere, publishing in top journals like Nature Biomedical Engineering, like on their N equals one experiments. One is Michael Snyder. You can look him up, or I can send you his multi-omics papers. Like, it's cool. Like, this can be hardcore, rigorous science, with internal controls, yada, yada, yada. You can get a lot of data. You can do hypothesis testing. You can develop models. Like, certain people have said it's not science. It is. There's no two ways about it. There's nothing that restricts the scientific
Mhm.
process from being applied to an individual. So
Can you steel man the counter argument here? What's the perspective of someone says you can't do N equals one science?
I don't think there's a steel man. I don't. I think it's a ridiculous position. Do you want to try to steel man it? And I'll respond to the steel man because I actually think I think it's ego defense. That's what I think it is. I've seen people who are like consider themselves scientists, like esteemed scientists, and I don't know if they're just trying to like it just seems like an ego defense. I don't think it's a defensible position.
I mean, I guess if I was to attempt to steelman this, obviously they're going to make arguments around generalizability and statistical significance. By definition, you can't compare two groups because the N is one, and therefore you can never generalize to the rest of the population. I think those would be like the types of arguments I would expect someone like that to make.
Yeah, but that's not it. So first of all, like you can still do statistics. Like I can collect multiple data points on myself and do statistics and get
Right,
p-values.
right.
Somebody on Twitter recently said on like an article that was published around me and N equals one, like, oh, you can't get p-values. I'm like, yes, you can. Like, I don't know what you're talking about. You absolutely can. You can have controls. You can have pre-post. It's intra-individual variability, like what happens before and after. Again, multiple data points. You can do statistics. And then in terms of generalizability, again, is the study matched to the question it's trying to answer? And if the
Mhm.
answer is with respect to individual health, I want there's a trade-off between the specificity and population generalizability.
Yes.
And if you care more about your health,
Right.
the specificity matters. I don't need to generalize. So take it from my perspective for a moment. Like if I engaged in this qualitative N equals one experiment with a ketogenic diet on my ulcerative colitis and healed my ulcerative colitis for
Mhm.
sake of argument, do I care as an individual if that's generalizable, or am I just happy that I'm not dying? Like, and
Yeah.
it's the
Yeah.
same with like many
Yeah.
people I've met with either weight issues or
Yeah.
mental health
And
issues,
and I think
XYZ. Like,
yeah, it's worth emphasizing too. Like there could even, I don't know, it's conceivable, right, that there could be larger scale data out there that might suggest that, oh, well, in this sample of 100 or 1,000 people, they saw no benefit with a ketogenic diet. That doesn't invalidate your N of one experiment for you.
right. So then there's the next level, which is it might not it has might have generalizable elements. So if we do it with enough precision and resolution, what can we learn, especially studying the outliers? So let's say I'm an outlier. I'm an
Yeah.
outlier in many ways. What is it about me that made me respond? And then in understanding that physiology, how can we use it to help more people? And we've done this in history again and again. I mean, talking about lipids, like Brown and Goldstein, they were studying very, very rare genetic conditions in lipids. Does it mean because their N value was only like 5 or 8 that their research was unimportant? No. They were studying outliers with unique physiology from which they learned something. So again, circling back to the main point, is N equals one science? Science? Absolutely. Is there any argument, any legitimate argument for calling it not science? No, not really.
Mhm.
Um,
It used to be more common, I think, in the early 1900s and before, for a lot of scientists to actually do their own self experimentation, often as sort of the basis to see, whether or not they even wanted to pursue a line of research.
right, right. I mean, it's good for hypothesis generation as well.
Yeah.
And I mean, speaking as the scientist, you can do certain experiments with a lot more rigor, actually more rigor in yourself than in other people. Because if you have a large population of people, say you're like doing like a diet trial or a feeding trial, it's like you can only control what they eat to so much extent.
Yeah.
You're doing it on yourself. Like when I did Oreo versus statin, like I know exactly what I'm eating with absolute certainty.
Yep. You
And I
don't have
can
to rely
actually
on
control
people
it and
filling out a survey or something.
filling out a survey or reporting what they ate or, even eating what you feed them
Yeah.
or, those kind of things.
I think this is
I
an
can
important
control
point
what.
too, because there's also there can be a lot of tricky. So the case of large sample sizes and quote unquote proper statistics can often obscure other methodological deficiencies in the literature. So the entire field of nutrition epidemiology, for example, I'm not going to say the entire field, but much of the field is, large sample sizes and fancy statistics, but it's all built on like flimsy survey data. And so it doesn't actually, those things don't actually matter
Right.
that much.
Yeah, no, but we get caught up in this hierarchy. So you can
Yeah.
come out with, oh, well, there's a meta-analysis
I had a
including
bigger
2
sample
million
size than you.
people. No, this happened recently, and I look at it and I'm like, it sounds nice. It's like, oh, we have 2 million people, and it's a meta-analysis conducted across like 31 cohorts, yada yada yada, the vanity metrics. But then you look at it and I'm like, but yeah, but look at the data. Two-thirds of your studies show no effect. The overall
Right.
effect size is tiny. There's conflict in the data. The reason for that is diversity in methodology. So you have just not only like you have taken specificity and thrown it into a freaking volcano. Like this does not necessarily represent a bigger truth. It's just, the alternative possibility is it's reinforcing misleading concepts with more perceived muscle.
Yeah.
And when
That's
you
a good way
start
of
to
putting
dig
it.
into like, well, what did actually each study find and why is there variation in the data, you come to very different conclusions.
Mhm.
So I am very much against this perception of a research quote hierarchy because sometimes it's just a way to reinforce pre-existing narratives, by not looking a level deeper at what's actually going on.
Mhm. Mhm. I want to talk a little bit about so things that have shifted in the recent past, technological changes, for example, that have enabled this type of self experimentation where it would have been difficult or impossible or prohibitive to do in the past. So what sorts of tools are enabling people like you to do high specificity research on yourself? I'm thinking
Right.
about things like at-home blood tests and other
Yeah.
devices.
Yeah, no, I'm actually open a kit right here that I just got in the mail. Things like continuous glucose monitor, so you can get real-time biofeedback on yourself. That's
Yep.
now like, approved to be over the counter. You have things like Aura rings and devices where you can get your own data on yourself. I'm partnering with various companies now to like make data more accessible. This is opening this kit. Like this is a kit from SciFox. Ooh, you can't really see it.
Put it a
Eh?
little. Oh yeah, it's a little blurry.
All right. What is it? Well, there we go.
There we go.
Basically like an at-home kit that you just put some blood on a test strip and it's going to give you your ApoB, your LDL, your HDL, triglycerides, HSCRP, your HbA1c, your total cholesterol, homocysteine, insulin, fasting glucose, ALT,
Yeah.
creatinine. Like you get the idea.
Yeah. I've used
Um,
I've used that one. It's great. Like you can
yeah, but I'm
see.
saying like there is, a demand for this and companies are listening and helping to empower people by getting their data in their hands.
Mhm.
There's more and more services to get data and there's more and more technology being developed. We're going to have, nice continuous ketone monitors soon, probably continuous multi-metabolite monitors. I bet you in 10 years, we're going to have toilets that will analyze your microbiome with every morning movement. And you can do N=1 experiments on your diet and your microbiome health. Like this is the way the field is trending to get more and more data on individuals and also develop technology to help process that data in the form of machine learning, AI, that'll help us see patterns and understand physiology in an unprecedented way at the
Mhm.
individual resolution level.
Mhm. Um, let's give people one or two fun examples of other experiments you've done. I'll let you decide what you want to discuss in the context of what you think is most useful to maybe help explain some of the concepts we were discussing earlier, things that people will find counterintuitive. Obviously, one that you did recently that I saw was the 720 eggs in a month. But
Yeah.
what have you found there, and what sort of misconceptions does some of that speak to in terms of things like blood lipids, cholesterol, and overall health?
Yeah. I mean, a lot of my recent experiments have had to do with pitting our understand like pitting the lipid energy model, which like is the model we just went over to conventional ideas around cholesterol. And so one experiment was where I added back a tiny bit of carbs in the context of eating 2 cartons of eggs per day, and my LDL went down. Another experiment I just did, I haven't released it in a video yet, but I did a vegan ketogenic diet and an animal-based ketogenic diet. So in the vegan diet, I dropped my saturated fat over fourfold. I increased my fiber a lot. I increased my polyunsaturated fat. All those things you'd think, oh, that should lower his LDL.
Hmm.
But I did one other thing that I won't reveal here, but aligns with the lipid energy model, to see, what would actually happen when I pit this one element of the lipid energy model against all the conventional ideas. My cholesterol, dietary cholesterol dropped to zero. My saturated fat went down. My polyunsaturated fat went up. My fiber went up. And yet, just spoil the results, my LDL actually went up, not down. Why? Because in this physiologic context, there are more important drivers than any of the conventional things. And so I use these metabolic demonstrations as one, teaching tools about what I consider cool physiology. But I think the broader idea around N equals one medicine is, empowering people to get excited about metabolic health and then apply the scientific method to their own life. And that's something that anybody, irrespective of their background training, can do. And, I've seen people, irrespective of language barriers or education limits, apply N equals one science to their own life to great health effect.
Mhm. Do you think there's, what are the potential dangers here, things we should be cautious about as it becomes as it becomes easier for people to do these types of self experiments? How should people think about balancing the advice they might be getting from their physician with their ability to tweak things and experiment on their own?
Yeah. Well, I always think you should have, like, I mean, irrespective of your training or background, I still have discussions with my physicians. You should always be open-minded. I mean, that's part of being a scientist, and get outside input, especially from people who have, a greater scope of awareness potentially than you of the field. So that includes your physician. I would never discourage anybody from having a good conversation with their doctor. That said, your responsibility, your health is your responsibility. Like, you should be at the helm of your own ship, because you're the one who is most aware of all the variables in your life and in most control of them. So you asked about caveats and limitations. I'd say, nothing that's not obvious. It's like there's the interpretive. There are going to be confounders potentially when you do an N equals one experiment. How rigorously are you doing it? What are you measuring? And did you change other things?
Mhm.
So can you really be confident that the intervention you meant to implement is having the effect you wanted? Or maybe there's a placebo effect. So again, there's in interpretive cautions. But these cautions and confounders happen, with in context dependent factors, really any science. So I think that is a limitation, but I don't think it's a one that actually, like, truly handicaps the approach. I think the not the bigger thing, but the thing that might raise more red flags is the safety element. Like, is somebody going to do something
Mhm.
that is unsafe and actually put them in harm's way? And I think this comes down to just, like, being a reasonable person. To be very clear, the experiments I do are not those that I'm recommending people do. Like,
Mhm.
I do not go just, like, eat extra Oreos and expect it to improve your health. That's a metabolic demonstration, not me trying to achieve a positive health outcome for myself.
Mhm.
Um, but the nice thing about, like, lifestyle interventions is usually pretty benign. Like, if somebody's going to try, like, a cold plunge or red light therapy or adding more fiber to their diet or even eliminating fiber from their diet or changing this or changing that, like, the risk profile is probably going to be pretty low.
Yeah.
And it will give people, useful data on themselves that I think they have the right to try to interpret and then also seek help interpreting. But the limitations, I don't think, the limitations which we can discuss, and I think we need to have open dialogues about, um, don't prevent this from being an incredibly powerful tool.
Yeah, and I guess even though you're doing more extreme or somewhat provocative things for the purposes of teaching and educating people on this, no, there aren't many people out there who are going to start eating hundreds of eggs per month or do the Oreo experiment. But there have always been people that are people have been trying different diets forever and ever, of all kinds, and it's just really nice now that people within that natural range of self-experimentation that the average person is already doing, trying one diet, trying another diet, there now is the ability to actually monitor your health, like, objectively, with biomarkers and with different things, so that you can really see in a way that you couldn't in the past how those dietary and lifestyle shifts are actually affecting your body.
Exactly. And what I would also say is, like, the scientific approach is, it's an attitude, like, people, when they go on diets, the way we conceive of diets in our society now, there's usually like a judgment to it. So like let's say you go on a diet and you don't lose weight. You might like say, "Oh, I failed this," or like get
Hmm.
angry at yourself, judge the approach, get frustrated, upset. That's not productive. But what if you take a curiosity lens to your lifestyle interventions? Then each of these, you know, interventions are data points, and you don't necessarily get discouraged. It's like, okay, this didn't work. Well, why didn't it work? That's interesting. Let me try something else. And if that worked, oh, why did it work? And is there, underlying thing that, is the driver for why it worked? And can I optimize that? Or can I try something else that like compounds the benefits? Being curious about the data that arises from your n equals one experiments generates, a growth and curiosity mindset that is incredibly, incredibly powerful. It's the thing that, like, when I see somebody's eyes light up with that element of curiosity, I know they're going to be successful long term in terms of their health journey.
Hmm.
Again, irrespective of their background, when it's just like, look, I actually find that treating my life as an experiment is a true pleasure, even if it means all the experiments don't have positive results. It's interesting. I'm learning about myself, and over the long arc of time, I am improving, and that's really, really cool.
Hmm.
So I think a lot of it has to do with a mindset shift for individuals, because, like you said, people are doing these things anyway. Like people are going to be trying diets. But what if you
Yeah.
do it in a little bit more systematic way and with a different frame?